All right, the first question is, how do we determine the length of the petals? Well, if we take a look at the coefficient in front of cosine, which is your A value, you can count how many circles it goes out. 1, 2, 3, 4, 5. This one goes out 1, 2, 3, 4. This one goes out 1, 2, 3, 4, 5. And this one goes out 1, 2, 3. All right, so this is the absolute value of A, because if you notice in the second one, A is -4, but it just goes out 4. All right, how can you tell from the equation how many petals there will be? Well, at first I would think that it's related to this other number, 3, because there's 3 petals here. 1, 2, 3. This one has 1, 2, 3, 4, 5. That matches up. However, when we look at this one, there's clearly not 2 petals. There's 1, 2, 3, 4. And in this one, there's 4 as a n value, but there's 1, 2, 3, 4, 5, 6, 7, 8. So we have different rules whether the n value is even or odd. So if n is odd, then it seems to match the value of n. So there are n petals. But if n is even, then it looks like we have twice as many. So we have 2n petals. All right, then it says, evaluate each of the above equations at theta equals 0. Compare this to where the first petal is located. Okay, so if we do r equals 5 times cosine of 3 times 0, that gives us r equals 5 times cosine of 0. And we should know from our unit circle, if we do cosine of 0, that's at 1, 0. So that's equal to 1. So that's equal to 5 times 1. And that's equal to 5. All right, if we think of this in terms of r comma theta, our answer should be r first, which is 5, and then theta, which is 0 degrees, or 0 radians. All right, and then if we keep going for the other equations, we've got r equals -4 cosine of 5 times theta. If we plug in 0, we get -4 times cosine of 0, which we determined cosine of 0 would be 1. So that would equal -4. So that tells us we should have a point at -4, 0. So remember, -4, 0 would be here, but if it's negative, we would go to the other side of the pole, and that would be at -4, 0. And then if we keep going, r equals 5 times cosine of 2 times 0. r equals 5 times cosine of 0, which is 1, so that gives me 5. So we have a point at 5, 0, which would be right here. All right, and then for our last equation, we have 3 times cosine of 4 times 0, which would be r equals 3 times cosine of 0, which is 1, and 3 times 1 is 3, so that gives me a point at 3, 0, which is right there. All right, so that takes care of our polar rows. When we have a cosine equation, we can also have a polar rows when we have a sine equation, and then we'll look at if things are similar or different. So if you count how many petals, 1, 2, 3, that matches up with this number, 1, 2, 3, 4, 5. That matches up with this number. This is a 2, so they should be doubled, so there should be 4, and this is a 4, so there should be 1, 2, 3, 4, 5, 6, 7, 8. And then how long are the petals? That is 1, 2, 3, 4, 5, which matches up with the A value. This is 1, 2, 3. This is 1, 2, 3, 4, 5. And this one is 1, 2, 3. So all of the properties so far are the same. All right, at what angle is sine of theta equal to 1? Well, think about your typical xy coordinate plane. Sine of theta equals 1 when the y coordinate is equal to 1, and that would occur at an angle of pi over 2. How can that be used to determine where the first petal will be? Third of the way to pi over 2. This one appears to be one-fifth of the way to pi over 2. This one appears to be halfway to pi over 2. And this appears to be 1, 2, 3, 4, 1/4 of the way to pi over 2. So, since theta equals pi over 2 when sine of theta is equal to 1, if n times theta has to equal pi over 2, then if we were to solve by dividing by n on both sides, we would get that theta is equal to pi over 2 divided by n, which is the same thing as multiplying by 1 over n, which is pi over 2n. So the 2n is in your denominator there. So that is when your first petal will occur. All right, how is the symmetry of the graph determined by the equation? If it's even, it seems to be symmetric over the y-axis and the x-axis. And that's when n is even. But when n is odd, it does not seem to be symmetric over the x-axis and the y-axis. It seems to only be symmetric over the y-axis. I could fold it in half here or here, but definitely not over the x-axis. Those would not fold in half. All right, so if n is even, it's symmetric over both the x-axis and the y-axis, but if n is odd, we think it's only symmetric over the y-axis. But let's take a look at when it's cosine. If n is odd, which are these first two graphs, it's symmetric over not the y-axis, but the x-axis. So let's put this in our statement. So if it's cosine, then it's symmetric over theta equals 0, which is the x-axis. And if it's sine, then it's over theta equals pi over 2, which is the y-axis. How can you determine the angle made between the petals? Well, if there's 3 petals and there's 360 degrees, then it should be 360 divided by 3. If there's 5 petals, then it should be 360 divided by 5, and so on, since they're all equally spaced. So in general, it would be 360 degrees divided by the number of petals. Or if we're talking about radians, it would be 2 pi divided by the number of petals. All right, so now we have a couple more shapes. We've got the circles and the limaçons. So for the circles, you could tell that if r equals 5 cosine theta, then the diameter is 5. And if r equals -2 cosine theta, then the diameter is equal to 2. We can ignore the negative sign, so that absolute value of A is equal to the diameter of the circle. Same thing for the ones that start with sine. We've got 4 as a diameter, and we've got 3 as a diameter, so the absolute value of A is your diameter. Now, in terms of symmetry, we can cut it along the x-axis, which is your polar axis, and that's theta equals 0. But for the sine equations, the symmetry is over the y-axis, which is theta equals pi over 2. All right, so if we take a look at the A value and see if it's positive or negative, in this case, when the A is positive, the circle is on the right side. When When a is negative, the circle is on the left side. So we'll say left of the pole. And when it was positive, it was on the right of the pole. And then for sign values, if a is positive, it's above the pole. And if a is negative, then it's below the pole. So when a was negative, it was below the pole. And when a is positive, it was above the pole. All right, so we can see the one that is on the left side is the only one that's being subtracted. The other ones are on the right side. But really what we need to do is compare the difference between A and B. So if we take a look at what's the value of A and B, which one is larger? Well, in this case, absolute value of 2 is less than the absolute value of 3. Here, the absolute value of 3 is equal to the absolute value of 3. Here we have 4 is larger than the absolute value of 3. And then here we have 2 is less than the absolute value of 3. All right, so what do we notice that's in common? Well, when A is less than B, we have a loop. So we will call that the loop limmason. And then when we have A equal to B, it doesn't have a loop, so we'll call that a cardioid. So we'll call it a dented limmason. All right, and then the last thing we could point out is that the maximum radius is absolute value of A plus the absolute value of B, and the minimum radius is the absolute value of A minus the absolute value of B. If we take a look at our max and minimum radii for each of these, we've got 2 plus 3 and 2 minus 3. That's 5 and negative 1. So you could see where it goes out to 5 and it goes inward a loop of size 1. That's the negative 1. For 3 plus 3 and 3 minus 3, that gives us 6 and 0. So it goes out to 6, and this is the cardioid part where it has a radius of 0. And then we've got our dented limmason. So 4 plus 3 is 7, and 4 minus 3 is 1. So it goes out 1, that's the least, and it goes all the way out to 7, that's the most. All right, and then the last one is 2 plus 3, which is 5, which would be our maximum radius, and 2 minus 3, which is negative 1. So here's your negative 1, the loop, and then it goes out to 5 at the largest. All right, and then what kind of symmetry do these all have? Well, these all have symmetry over the x-axis, which is the polar axis, which is when theta equals 0. All right, if the equation had a sine instead of a cosine, what type of symmetry would the graph have? When we had circles, we had symmetry over pi over 2. When this had a sine, we would have symmetry over pi over 2. If the equation had a sine instead of a cosine, the symmetry would be at theta equals pi over 2. It says find the average rate of change between theta equals 0 and theta equals pi over 6. So write a sentence to interpret your answer. So as a reminder, this would essentially be like finding your slope. Your change in y, which is your f of theta, over your change in x, which is your theta. So we want to figure out, well, what happens when we substitute in pi over 6, and what happens when we substitute in 0, and then pi over 6 minus 0. All right, so let's just do f of pi over 6. So that would give us 5 times sine of 3 times pi over 6, which is 5 times sine of pi over 2. Pi over 2, remember, is the ordered pair 0, 1, and the y value would be your sine, so 5 times 1, that would equal 5. So r, theta would be 5, pi over 6. And then for f of 0, you would get 5 times sine of 3 times 0. And sine of 0 is equal to 1 comma 0, which is 0. And that would give me 0. So this would give you 0 comma 0. Slope between those, we're doing the f of pi over 6 first, which gives me 5, right? Then we're doing the f of 0 next, which when I plugged in 0, I got 0. And then I found the difference between the two angles, which is pi over 6 minus 0. So it's 5 over pi over 6, which is equal to 5 times 6 over pi. So that gives me 30 over pi. All right, so if we want to set up a sentence to interpret our answer between the two angles, right, between theta equals 0 and theta equals pi over 6, what's changing? The radius changes at a rate of, what we just found is our answer, 30 over pi for every radian on average. Right, so the on average part takes care of our average rate of change. All right, so for this last question, we're going to consider the distance from the pole, and we're going to use this function -2 plus 4 cosine theta. We're going to complete a table of values. So if I were to plug in 0, I have 4 times cosine of 0. Cosine of 0 is 1. So 4 plus -2 is 2. If I were to plug in pi over 3, pi over 3 is like a 60-degree angle. Cosine of a 60-degree angle would give me 1/2. And 1/2 times 4 is 2. 2 plus -2 is 0. If I were to keep going, pi over 2, so cosine pi over 2 is 0, times 4 is 0, plus -2 is -2. 2/3 pi is in quadrant 2, but with a reference angle of 60 degrees, so that gives me -1/2 times 4, that's -2, plus -2, that's -4. Pi would be -1 comma 0, so the cosine would be -1. 4 times -1 is -4, plus -2, that's -6. 4 pi over 3 is a 60-degree reference angle in quadrant 3, so the x-coordinate's -1/2. 4 times -1/2 is -2, plus -2 is -4. 3 pi over 2 is 0 comma -1, so cosine is 0. Times 4 is 0, plus -2 is -2. And then 5 pi over 3 is in quadrant 4 with a 60-degree reference angle, so +1/2 times 4 is 2. 2 plus -2 is 0. And then 2 pi is back to 0 again, so you should get the same answer, which is 2. All right, so on the interval from pi over 2 to 2 pi over 3, that's from here to here, is the distance between f of 0 and the origin increasing or decreasing? Well, we can see that from -2 to -4, those values are decreasing. And the values of r are negative, which means that if we're talking about how far away it is from the pole, it would be 2 units away and 4 units away. So it would go from 2 units to 4 units. So that would mean that the distance from the pole or the origin is increasing. So the overall answer is that the distance between the function and the origin is increasing. So if you look at my radius, was it increasing or decreasing? It was going down from -2 to -4, right? The radius was decreasing. The radius is negative in both of those. So that means that the distance from the pole is getting bigger and bigger. You can use this little chart if that helps. Otherwise, just think of it as the absolute value distance from the origin.